Hello, so we're in Random Week, and we've already looked at waveforms, including, well, mostly non-random waveforms like sine waves and so on, but also random ones, which leads in nicely to this session, focusing more on random numbers and all the functions you can use in Tidal for playing with them. Let's first of all think about what random numbers are. And I've dug out a video of myself generating some music with random numbers. So you can see I'm pressing a button to get a number out, here 5, and then I'm using that, just treating that as a musical note. So I'm playing the 10th note in the octave and gradually building up a melody. Not a very good one. So I guess I'm showing this to kind of think about what random numbers really are, and actually numbers aren't random. What's random is the way of generating them, but once you've rolled some dice and got the number 7, it's not the number 7 that's random, it's the same number 7 as if you just thought of it, or if you got it by adding together 4 and 3. They're all just numbers, and so if you have a list of numbers, that's not a random sequence, it's a randomly generated sequence. I think that's important as a step to treating numbers, random numbers, not as having some special property, but just being arbitrary. I think too much is made of random numbers in algorithmic music in general. People think that even the definition of algorithmic music is random music. I think Brian Eno is a lot of the problem here. But so randomness, I mean, even in Tidal, in the first few years of its development, I didn't bother putting randomness in, because actually randomness, it's just like something like white noise is a random source. It's just like taking something that's completely unstructured. It's got maximum information in, which is the same as having no information in at all. So really, to me, if you use random numbers, it's just like an arbitrary decision. You're instead of making a decision about something, you're saying this isn't important. Or maybe another way of looking at it, which is maybe a bit more productive, is treating it a bit like silence. Like silence is the opposite of randomness in a way, because silence has no information and randomness is maximum information. But in terms of its musical quality, they both have no structure. They both are different ways of giving some ground to some figure. You know, it's like giving some space in a composition so that you focus on something else. So that's my little mini rant on random numbers, which I might return to during this lesson. Actually, I've got quite a lot to get through, so I might break this up into a couple of videos. Let's see. So we've already seen rand. Let's jump into the code. We've already seen rand. So if we had a drum pattern, like just a simple one. And we wanted to have the speed randomize. We can do that. And now every note has a random value between 1 and 2, because we're adding 1 to a random function which only gives values between 0 and 1. So adding 1 to it just gives it between 1 and 2. If we make this simpler but more frequent, so there's a couple of things here. The first is that this random pattern It is infinitely detailed. The more you look at it, the more numbers there are. So it's not it has no structure, which means that it has infinite number of values per cycle, and you're just sampling values from that. But the other thing is it's completely deterministic. It is actually a function of time, like everything else in Tidal. So if I use resetCycles, this is a function which just resets the cycle count to 0. So it's as if you just started Tidal up. So if I run that and then run this, you should be able to hear that each time I hit resetCycles, it plays the same sequence. So again, that random sequence, it is actually the same every time you run it. It's just that if you keep Tidal running all the time and then run a pattern, it'll sound different because you're hearing a different part of that pattern. And it'll go on forever, infinitely, generating new numbers. But once you hit that resetCycles thing, you can hear the start again. So here I'm using a function called repeatCycles, and telling it to play cycles, 4 cycles, repeat the cycle 4 times, each cycle 4 times. So you can hear the pattern in the music, even though the source is randomly generated. That's interesting. We're really good at hearing repetition. So even if those numbers are generated in a really arbitrary way, we can still hear that period in it. And you'll probably be able to do it even more the faster I go. Yeah, so you can hear the period, you can hear the repetition, even though there's like 16 sounds that you have to recognize. You somehow group them together in a kind of perceptual gestalt, as the Germans call it. Okay, so that's what we looked at last time, with a bit more armchair philosophizing about randomness. Basically, it's a pattern, a waveform that's randomized. And there's another one which we didn't look at last time, but is also useful, and that is iRand. So if I, for example, use this and put iRand 8 here, again, that won't make any sound because random functions don't have any structure. So I have to give it a bit of structure first. So I can do that like this. So the difference here is that it's a stream of random integers. Integer is another word for whole number. And I've given it a number to say what range should be. So this will actually give pick from 8 possibilities, but starting at 0. So it'll return a number between 0 and 7. And I'm adding 24 to it so that it's then between 24 and 31. Rash, by the way, is from the Samples Extra package we installed at the start of the course. and that has a note, a sample per note. So you can treat it as if it was a synthesizer, but actually it's another sample pack. It's just organized in order of notes, and there's several octaves in there. So several octaves worth of notes. Okay, so that's another thing you can do is to generate random numbers. Something that we'll look at later in the course is actually treating this as a major scale. So now, instead of just picking from all the notes, it's just picking from notes in the major scale. So it sounds a bit more musical. We'll do that in the next week after the break. Okay, so that's randomness of integers. Let's have a look at the mininotation for a moment. So there are random things you can do in the mininotation too. So let's go back to our old favorite CPU. So that's 4 different sounds. And I can put, instead of using a comma, I can group together sort of sub-patterns, sub-sequences using this vertical bar. And what this means is just pick one of them per cycle. So this could be a longer subsequence. So there's 4 subsequences, and each time round it'll pick one at random. So that could just be one step within a longer pattern. So it'll always play the 0, it'll always play the 2, always play the 3, but this second step will be picked from this set of possible subsequences. I think in music, traditional Western classical music, this is called an ossia. I think someone who's musically trained will quickly correct me on that, but let's see. So that's a random choice. You can also just choose whether or not to play something. So if I have some kick drums, the 4th one, I want to be optional. So there's a 50-50 chance of this 4th kick drum. Let's make it a clap to make it a bit clearer. So half the time it'll play the clap, half the time it won't, on average. You can adjust that by doing a number afterwards between 0 and 1. So if I want it to play 90% of the time, I can do that. And we'll have to, there's one. Or maybe it's 90% of the time it doesn't play it. That would, yeah, I think that's right. So to be 90% chance of playing it, I do the opposite. I do 10%. You can actually do this with a group of notes, but then it'll each one within there will have the chance of playing or not. So this would be a kind of random kick pattern. Okay, so the question mark is for having something play or not at random within mininotation, and the default is 50%, but you can adjust that if you want. Okay. So that, I think, is all the randomness you can do in the mininotation, but you can, even with those 2, that can add a lot of variety to something. Okay, so the next thing is 2 functions which are pretty similar to each other. So let's pick some melodic notes. So that's a simple scale. So let's say we wanted to scramble this so that those notes would play at random. We could do scramble 4 because there's 4 of them. So that's kind of mixing them up. So it's saying put this into 4 bits and pick random bits all the time. If I have 4 bits and there's 8 things here, it'll separate them into pairs. So it'll either play these 2 or these 2 or these 2 or these 2. So it's always playing, in this case, a note followed by one higher because that's what's in the pattern. Gives it a bit of form even though it's a bit random. So shuffle instead, so it's got the same sort of shape, the same type structure. So it sounds pretty similar. It's just doing something a bit different. In the case of scramble, it's picking these at random. In the case of shuffle, it's taking those 4 things and changing their order, which means that each cycle, it's still going to play every one of them exactly once. It's just that they'll be in a different order. In the case of this one, it will just play them. It might even just play the same one 4 times. It's unlikely, but it's possible. Whereas in this one, you'll only get each one once. Right, so you've still got quite a few to do. Let's do this group, and then I might pause and we'll continue in the next video. So choose. So let's say we wanted to choose some sounds from a list. We could do this. So we could have BD, or we could have RP, or we could have kick. Again, it's a random source, so there's no structure here. If I just wanted 1 per cycle, I could do this. If I wanted 4 per cycle, I could do this. If I wanted to kind of have a binary structure with true values using a Euclidean function, I could do this. So there you go. And so that's just picking one of those at random for each sound. There is also wchoose. So what's the difference? In this case, these each have the same likelihood of being picked. A way of making it so that BD is more likely than others of being picked is just to put it more than once. So now there's 2 chances of BD being picked and only 1 chance of RP and kick being picked. So there'll be twice as much BDs as RPs. Or 3 times as much in the case of this edit. That's actually a quick way of adjusting the probabilities, but you can also use wchoose. I'm just going to double check the order of things there. I can see from this that wchoose wants a list indicated by these square brackets, and in that list is a thing, and then how likely it is as a double, which is a kind of floating point decimal number, and then you get a pattern. So let's do that. Let's have some BDs. Let's have wchoose. In this case, I'm going to use my currently favorite effect, which is squiz, contributed by the mighty Callum Gunn. Thanks for that, Callum. I've been squizzing everything. So let's say we want a squiz of 2, fairly likely, so 3, a weighting of 3. So the W in choose stands for weight. So the weight is how probable it is to happen. And in this case, I want it really squizzed, but quite unlikely. So relatively, this is now, I think, 5%, 5 times out of 100, which isn't very much, because this is a weighting of 2. This is a weighting of 0.1. It's going to be pretty rare that we hear that really squizzed. Oh. I've gotten the wrong way round, that's why. Yeah, so now it's, yeah, sorry. So it's the first one that's the value, and it's the second one that's the weighting. So let's try that the other way around. That's what I intended. Okay. So now, most of the time it's 3, but every now and then, it's actually 5% of the time. So 5 times out of every 100 you get that bigger squiz. Just had one. It's pretty unlikely. And we can add more to these. So let's add, let's have it really squizzed, and 0.5. Seems that maybe you can't hear the difference between 8 and 10, so that's maybe not a good choice. Yeah. Okay. So that's quite nice, playing with the probabilities to give a different kind of shape to the randomness. You might find yourselves doing that kind of thing a lot, sort of having a random source, but then playing with it, playing with the parameters, so you start getting the kind of texture you want out of it. So one last thing I wanted to cover before I finish this video is, so we already said at the start that there's just like one stream of randomness, and that can result in some pretty unexpected things happening. Because there's only one stream, you find that if you've got 2 different aspects of the sound randomized, then they'll interact. So let's have a look at a simple example of that. So let's have our simple kicks again, and just put a random thing on the panning. So now, when it's 0, it's in one speaker. When it's 1, it's in the other speaker. When it's somewhere between, it's somewhere between the speakers. And if we also do something to speed with rand, let's give that a range from 1 to 3. So they're both randomized, but it's the same random stream. So that means that the panning will get the same random numbers as the speed, which means that it'll be high in one speaker, which I think for you will be on this side, and oh no, yeah, that's right, on this side. I think I'm getting confused with stage left and stage right and things. Anyway, on one side it'll be high, and on one side it'll be low in pitch because of this. The speed of playback is changing, and these are tied together, which is actually kind of nice. It gives a bit of flavour to the music, which you could take as a musical idea and develop in interesting ways by adding other things which come from the same stream. For example, but maybe you don't want that to happen. Maybe you want them to be distinct. And there's different ways of doing that. If you just, for example, sped up one of the patterns by a tiny amount, that would immediately disassociate them. And that's because you'll be because this random number is random pattern is sped up. You're very quickly find yourself drifting off in different parts of the timeline, or you could just shift it by 1. Oops, you can't do that with operators. And that would mean that this random pattern was offset by 1 cycle, so that you might be able to perceive one following the other, but they'd be offset by 1 cycle. In this case, I think you'd be pretty amazing perceptual being if you were able to perceive that. But you could try. Or you could just make it like a really long number, and then they'd be really, it would take 100 million cycles before you'd get to the same part of the random stream. Okay, so that'll do for now. I'll be back to cover the rest of these random things in the next video. So I'll see you then.